Okay, excuse me. Assignment number 6. Watch the assignment number 6 video, which you're watching now, and complete the assignment number 6 organizer. ICANs for the next few days are be able to describe the bonding of atoms by losing, gaining, or sharing electrons to form molecules or three-dimensional lattices. Gaining, losing, and sharing electrons will result in atoms within the compound becoming stable, full electron shells, which we know as having 8. You also should be able to define ionic compound and describe electron movement and attraction in an ionic bonding of two given elements. ICAN number 2, define an ionic bond. An ion forms when atoms gain or lose electrons and become charged. And we've been practicing forming ions since last unit. You watched the BrainPop video with me where these two sad face elements, this one has one electron in its outer shell, this one needs one more in its outer shell. So this sad face person here steals, this sad face person here steals that one. Now this one becomes happy and that one becomes happy, forming ionic bonds. Here it is again. We had this sad face person giving away an electron and becoming positively charged, and this element stealing one, becoming negatively charged. We've got a positive charge there and a negative charge there, which creates positive and negative ions. An ionic bond involves the attraction of two oppositely charged ions, typically a metal. Remember, ionic bond is between a metal cation, the positive thing, the metal, and a non-metal anion, the negative thing, formed by transferring electrons between the two atoms. So an ionic bond is formed when atoms transfer electrons to become charged, and that oppositely charged positive-negative attraction is what forms the ionic bond. So number 1 on your paper was, how do ions form? Ions form when atoms gain or lose electrons and become charged. Number 2 on your paper, remember you can pause this, so I'm just going to keep going. Number 2 on your paper, what causes ionic bonds to form? Again, it is that gaining and losing electrons, the transferring, it's right here, the transferring of electrons between atoms causes ions to form, and it's the attraction between oppositely charged ions. That's what causes an ionic bond to form. Attraction between oppositely charged ions. Attraction of two oppositely charged ions. Why does that happen? Because they gain and lose electrons. We are now going to learn how to name ionic compounds. There is number 3 on your paper says what two classes of elements form an ionic bond. Remember that you have a metal and a non-metal. Two classes of elements that form ionic bond is a metal and a non-metal. The way that you name them, number 4, it says to list the steps for naming ionic compounds. First, you need to write the metal ion. That's the first step. Second, you need to write the non-metal ion. And third, you need to change the ending of the non-metal to IDE. For example, right here is sodium chloride. So sodium plus chlorine, what will we name that? SODIUM, sodium, that's our metal. And our second element is chlorine, CHLOR. And instead of being ene, it's going to be chloride, IDE. So you write the first element, the metal first, and then the non-metal you change to IDE. And here is the list of elements. Right here's the list of IDE endings for all the nonmetals. So you need to, in number 4, you need to write down these steps right here in number 4. You need to write down these 3 steps in question number 4 and list these IDE endings in number 5. So when it's fluorine, you change it to fluoride. When it's chlorine, you change it to chloride. When it's bromine, you change it to bromide. When it's iodine, change it to iodide. Hydrogen is hydride. Oxygen is oxide. Sulfur is sulfide. Nitrogen is nitride. Phosphorus is phosphide. Carbon is carbide. Selenium is selenide. So write all those down in number 4. Your screen doesn't work in presentation mode, so I'm going to have to go out of here and try it. Oh, I'm pushing the wrong button. Cool. Pause it, do what you got to do to answer 4 and 5, and then let's practice constructing ionic compounds. So these steps are already listed in your paper. You've actually got a 4th step, a 5th step, which is to name it. On yours, it's letter E, name it, because we just practiced naming. We're going to do it right now. So draw the dot diagram. Here's the first one that we're going to do. There's paper, there's space on your paper. You need to do this. Draw the dot diagram first, right here. We're on step number 1. In that empty space below number 6, Na has 1 valence electron because it's in group 1. Chlorine has 7 valence electrons. Chlorine has 7 valence electrons. Oh my word. One, two, three, 4, 5, 6, 7. So check. We did number 1. We drew the dot diagrams. Now we're going to show the transfer of electrons. Sodium needs to get rid of 1, and chlorine needs to have 1. So this is how you show it. You draw an arrow with an X. It has transferred the electrons. That's step number 2. Write the ions formed. So this is a separate thing. Na lost a negative, so it's positive by 1. And chlorine gained an electron, so it's negative by 1. There's the 2 ions that are formed. Write the formula. The sodium and the chlorine involved in this bond are both happy. They both have their full valence shells. We don't need to add any more elements. So the formula is, how many sodiums do you have here? 1, Na. How many chlorines do you have? 1, Cl. That's our formula. And now what are we going to name this? Sodium is the first element. Change chlorine to chloride, CHLORIDE. Most of you are thinking this is super easy, and you're right, it is. So that's the first one you need to do with me, all of these examples. And I'm going to check your paper to make sure that you wrote down all the examples with me. Example number 2, magnesium and chlorine. Step number 1, draw a dot diagram. Magnesium is in group 2. Remember, I don't need to go slow because you can pause this, do what you need to do, and then start doing the video. Chlorine is in group 17. It has 7 valence electrons. Magnesium is going to give 1 away right here. Now this chlorine is happy, but look at our magnesium. It still has another electron right there that it needs to get rid of. So you've got to draw another chlorine. When reactions occur, when bonding occurs, there are billions of atoms around. So we're not making up stuff. This is what happens. There's another chlorine floating around there, and magnesium gives its electron away. And now you have 2 chlorines bonded to 1 magnesium. So that's the first thing. We drew a dot diagram, check. We showed the transfer of electrons. Now we need to write the ions formed. I've got to clear the screen, but remember we've got 1 magnesium and 2 chlorines. So we write the ions for Mg gave away 2 electrons, so it became positive by 2. Cl, each individual Cl, you're looking at the individual ion itself. 1 chlorine atom looked like this. 1, 2, 3, 4, 5, 6, 7. It stole one more. The chlorine became more negative by 1. So it's 1 minus. That's the ions formed in step number 3. Write the formula. The formula, if you remember our picture, we had 1 Mg and 2 Cls because magnesium had those 2 electrons to give away. We needed 2 Cls for that to happen. So the formula is MgCl2, and the name is Mag, N-E-S-I-U-M, magnesium. Chlorine gets changed to C-H-L-O-R-I-D-E, magnesium chloride. If you're having problems with this and you need to come see me, pause the video and come talk to me. We're doing it right here in class, so come see me. Otherwise, keep working on the examples. Next one, rubidium fluoride. Rubidium is in group 1, so it has 1 dot. Fluorine is in group 17, so it has 7. 1, 2, 3, 4, 5, 6, 7. Draw dot diagrams. Show the transfer. Write the ions formed. Rubidium gave 1 away. Fluorine got 1 more electron, so it's 1 minus. Write the formula. They were happy with 1 of each. R, B, F. They both have a full outer shell, and it is rubidium fluoride. Rubidium fluoride is the name for step number 5. That's what you would name it. The next one is beryllium oxide. Be has 2, and oxygen has 6. 1, 2, 3, 4, 5, 6. Beryllium gives 1 here. Beryllium still has 1 to give away. Oxygen also still needs 1. Ions formed. Be, drew dot diagrams, showed transfer. Do ions formed. Be gave away 2, so it's more positive by 2. Oxygen gained 2 negatives. And the formula, how many Be's and O's did you have when everybody had a full outer shell, 1 of each, and you would name it beryllium oxide. Go ahead and write it down. Didn't require you to O-X-I-D-E. I'm not confident in my ability to spell beryllium, and I didn't make you memorize how to spell them, but you should have a periodic table in front of you, so write it down, beryllium oxide. Write the formula, did the name. Next one, in A has 1, sulfur has 6. Sodium is 1 away here, but sulfur still needs 1, so you do another Na. Ions formed. Your individual Na ions, you have more than 1 Na ion, but the Na ions involved in this picture all gave away 1. So they are 1 plus. And your sulfur got 2 minus. Now our formula, how many NAs, how many S's are there in this whole picture? Once everybody's happy, everybody has a full outer shell, Na2S. Last one, MgP. This is the most complicated one. Mg has 2. P has 5, right? Yes, P has 5, 2, 3, 4, 5. Mg gives 1 away there, and it gives 1 away there, but P still has a hole, so we need another Mg. Mg, 1, 2. We have that one there, but now Mg still has 1 to give away, so we need another P. P has 5. Mg gives 1 away there, but now it has 2 that it needs. Is this ever going to end? 1 more Mg will probably do it. Mg has 2, and 1 can go there, and 1 can go there. And now everybody is finally satisfied and happy. Ions formed. Mg ions all gave 2 away. plus 2. The phosphorus ions all stole 3. They all got 3. They've got 3 negative. What's our formula? Look at your picture. This whole picture right here. Mg3P2. And what's the formula? The name? Magnesium phosphide. Magnesium phosphide. So that's the end of assignment 6. Bonding assignment number 6. Do the rest of number 6. There's a whole ton of practice problems you should be doing now. So come and ask me for help, clarify any questions that you have. I'll do some with you individually if you need the help. That is the end of bonding assignment number 6.